Hello, my algebra doing friends. Welcome back after spring break. So here's our game plan. Monday begins week 12, and so here's our progression. And you notice that our next test is in week 14, and so on chapter 8 and chapter 9. The homework. I put the notes on Canvas so that you can print it if you like. And so you don't have to print it if you don't want. The homework is on that second page of the notes for all of chapter 8 and all of chapter 9. And then we start the notes. And so this is 8.1, and I also tried to put the homework on each individual page as well. So this is talking about rational exponents and also square roots and cube roots as well. So it has quite a bit of things in it, as well as, remember the word rational meant fraction. So fractional exponents is going to be in this section as well. And so how the principal square root or the positive square root is defined in your book, it's the square root of x, quantity squared, equals x. And so that's what you would be looking for that square root. One way of thinking about it is thinking to yourself, what, when I square it, gives 121? This pencil's not that good. And there's two things that when I square it yields 121. One of the things is 11, and the other thing is negative 11. And so here, because they're asking for the principal square root, they're asking for 11. And so because 11 squared equals 121, they're asking for the positive one. And so the square root of 121 equals 11. Here, they're saying, okay, what, when I square it, gives 144, right? And there's two things. There's 12 and there's negative 12. And because they've used negative root, that's the symbol for the negative square root. And so the answer here to this is negative 12. Right, because negative 12 squared is 144, and so this is our answer. Of course, in the back of the book, on number 2, they just have negative 12 as the answer in the back of the book. So here on number 4, the same question, right? The question is this: what, when I square it, equals negative 49? And I hope that you're thinking, well, it's not 7, right? Because when I square 7, I get positive 49. And it's not negative 7, because when I square negative 7, I get positive 49. And so it's actually that this cannot work. This is not real, is what they have in the back of the book. It's not a real number. The square root of negative 49 is not a real number. The radicand, that's the part underneath the square root, is called the radicand. And so that part underneath the square root is called the radicand, and it must be non-negative. And so our radicand has to be greater than or equal to 0. And then this one here, this example, the square root of 9 over the square root of 25, or the square root of 9 over 25. And so, so I'm thinking, what, when I square it, this is my thought. And so normally you don't write your thoughts, but this is what I'm thinking, right? This is what I'm thinking. What, when I square it, gives 9 over 25? And well, this would have to be 3 squared is 9 over 5 squared is 25, right? And so the answer to the square root of 9 over 25 is 3/5. Okay, so we did a lovely job on that page, and they give some more definitions here on the next page. Here they say that this is the same as this, which is equal to x, if x is a non-negative number, and the fourth root of x raised to the fourth is the same as the fourth root of x to the fourth, which is equal to x if x is a non-negative number. And I have ... here and you can't see it, it's right here, but it's not very bright, dot, dot, dot. So this would continue. This was the square root, the fourth root, the sixth root, the eighth root. And so this is true as long as our index, so the root that we're taking, so this was the square root, this is the fourth root, that's called the index, the 4. And so as long as this is even, almost spelled even wrong there, then x must be a negative number. Cube roots and fifth roots, odd roots, are much nicer. You don't have to make sure that your variable x there is a non-negative number. And so if you're thinking about the cube root of x raised to the third, quantity raised to the third, that's the same as the cube root of x to the third, which is x, and etc., the fifth root, and dot, dot, dot. Here's my dot, dot, dot. It continues as long as we're odd. And so this would be true. And so two ways of thinking about this then. And so when I think about, and of course your calculator will do a cube root, but when I'm thinking about it, this is what I think in my head. What raised to the third, because it's a cube root, is equal to 27. And 3 raised to the third, because 3 times 3 times 3 is equals to 27. So the cube root of 27 is 3. And you can go and find that on your calculator and give a try to it. The nice thing about cube root, and that's what this was saying over here, is that when I think about this, right, I'm thinking to myself, what raised to the third equals negative 27? And before we said on a square root, oh, it can't be. But on a cube root, all you have to do is put a negative in there, because a negative raised to the third is a negative. So this would be negative 3. So the answer here is negative 3. So I don't have that problem that it's not a real number like I did on square root. And so I guess I have the note, hey, 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 when you're radicand, when you're having a cube root, the radicand of the cube root does not have any restrictions. So it could be positive or it could be negative. And so some other problems that they ask us here, they're asking us to find, and you can practice these with your calculator and also with your head. They're wanting you to know them with both, right? And so I'm thinking to myself, I'm thinking what raised to the third equals negative 8? And so that will answer just that part of it, right? The cube root of negative 8. Well, yeah, it's negative 2. And so this symbol, this negative, is negative of, then what was this? Well, it was negative 2. And so negative of negative 2 is positive 2. So we did a lovely job on that. Now here, there's an issue. Because when I try to do, when I do my thought here, what raised to the fourth equals negative 16, right there. Well, there's nothing when I raise it to the fourth, nothing that is real anyway, that when I raise it to the fourth, I get negative 16. And so this is not real. Not a real number. Missed the word a there. Not a real number. Okay, and so now they're asking us, they say, hey, the variables, assume the variables represent non-negative numbers, and they're wanting us to think about this. And of course, there's two ways of thinking, and how I think about it is I think to myself, because it's square root, what to the second equals 49, a to the 10th is what I think. And then that gives me my answer. And you get where you don't have to think this way. You don't have to write that out. Well, 7 raised to the second is 49. And what, when I raise it to the second, will I get a to the 10th? Can you guys think of anything? I can almost hear people saying a to the 5th, right? And so this is 7a to the 5th. And then here is the cube root of 8x to the 15th, problem number 20. And I'm thinking to myself, what raised to the third, because it's a cube root, equals 8x to the 15th? And so 2 raised to the third is 8, right? And can you guys think of what you would raise to the third power and get x to the 15th? X to the 5th, right? So those rules that we had back in chapter 4, that you would multiply those exponents, is kind of what you're using there. And so the answer to the cube root of 8x to the 15th is 2x to the 5th. And so there we have that. Now, we did not have to assume that x was a non-negative number for this cube root. But in order to do this square root, then we needed this assumption if we were going to use what it was equal to here. Anyway, so that's kind of that story. So here, this is problem 26 rather, excuse me. I'm thinking, what, when I raise it to the 4th, gives 81, a to the 24, b to the 8. And so you could use the 4th root on your calculator to take the 4th root of 81 and find out what it was if you needed to. But I know 2 to the 4th is 16. And 3 to the 4th, so 3 to the 4th, right, is 3 times 3 times 3 times 3. So there's a 9, and there's a 9. And 9 times 9 is 81. And so 3 to the 4th is 81. So this is 3 in here. And I want to get raised to the 4th, and I want it to equal 24. And remember that, that it was the multiplication, right, of the exponent. So this is a to the 6, because 6 times 4 is 24. If you're thinking, isn't it division? 24 divided by 4 is 6. The answer is, yeah, you're right. And b to the 2nd, right, to make 8. And so our answer to this is my thought. This is what's true. And so this means my answer is 3a to the 6, b to the 2nd. And here is the 5th root of 32x to the 10, y to the 5th. And so I'm thinking in my head, what raised to the 5th equals 32x to the 10, y to the 5th. You'll get where you don't have to write it, that you can just think it. And so, but I want you to know what we're thinking in order to figure it out. 2 raised to the 5th, we've done that so many times that I imagine that you know that 2 raised to the 5th is 32. You get where you memorize some of those. And they come up so often. And x to the 10th, well, that has to be x to the 2nd, right? And y to the 1st, y to the 1, I'm squeezing it in because 1 times 5 is 5. And so this is 2x to the 2nd, y to the 1st. And of course, in the back of the book, they're not going to write y to the 1st, they're just going to write y. 2x to the 2nd, y. So we needed that the variables were non-negative in order to do the 4th root. But the variables, they didn't have to say anything. The answer would have been the same if because of the 5th root. And so it would have been okay there. And then another definition that they give you, and this is where it comes up the fractional exponents, is x raised to the 1 over n. So that's a fraction. 1 over n is the nth root of x. And so what this means is x to the 1/2 is equal to the square root. And so in my index would go a 2. And when it's a square root, I don't have to write the 2. I can just write it like this, the square root of x. And so x to the 1/3 would be the cube root of x. And I would need to write the 3 in the index. I couldn't stop writing the 3 in the index like I do for the 2. And then we'll come on this definition in just a second. And so then just a note, remember that when you have a square root, you have to be careful. And when you have cube roots, you don't have to be that careful. And so the first problem that we're going to look at, and you can use your calculator to check it. I had my calculator here around. It was floating around here earlier, and here it is. So, because I want to show you how to put these in your calculator, so I want to make sure I have it. So number 28 is 49 raised to the half. And so by our definition, this would be the square root of 49. And then hot diggity dog, I know the square root of 49, it's 7. And so, but I want to show you that you can put that in your calculator. So 49 and then raised to, so I hit the raised to key there. So I typed in 49 and then I hit the raised to key. And then I want to raise to the half. And I can write 1 divided by 2 like that if I like, and that works. The other thing I can do if I like is I can hit the fraction key while I'm here and have 1 in the numerator and 2 in the denominator, because that means, right, 1 divided by 2 is the same as 1/2 as written as a fraction. And then do the calculator, let it do it, it'll give you 7. If you do the square root of 49, it also gives you 7. So you can also use your square root key there. So we did a lovely job on that. And so this right here, negative of 16 raised to the 1/2, this negative is on the outside and is not part of the base. And so we've seen that lots and lots of time. I'll remind you, we saw this when we said negative 3 raised to the second. Do you guys remember that? And we said that's negative 9 because the negative wasn't part of the base. And that's the same thing here, is that I have my exponent half and my base is 16, but the negative is not part of that base. So this is negative of square root of 16. I almost said 4. I almost said the square root of 4, but I was doing the square root, right? The square root of 16 is 4, so this is negative 4. And of course you can put this in your calculator just like you see it. So the negative and 16 and raised to, and then a fraction if I like, half. And then it will give you the same as what we got, negative 4. And so that was problem 30. Now here's problem 38. And so this is, because this is raised to the 1/2 here, so this is the square root of 9 over 16. And we know the square root of 9 over 16, that's 3 over 4. Right? The square root of 9 is 3, and the square root of 16 is 4. So our answer there is 3/4. Now this is saying for the fifth root, right? The fifth root of 32. And we've actually done that one today. The fifth root of 32 is 2, right? Because 2 raised to the fifth is 32. And the good news is you can do it on the calculator as well. So if there's some of them you don't know, you can put them in. So this is 32 raised to the 1/5, which is 2. And then the parentheses are around the base. So the whole base is negative 8. So this is saying the cube root of negative 8. And we've done the cube root of negative 8 today, right? We're thinking to ourselves, what raised to the third equals negative 8, right? And it was negative 2. And of course, if you put it in your calculator, it'll do a Jim Dandy job of it. So we got here parenthesis and then negative 8 and then raised to, I'm going to put in 1 divided by 3 this time, my choice, and I get negative 2. And so it certainly will do it. Now this one here, number 42, has not a 1 in the numerator like the rest of these did. 1/5, 1/2, 1/2, 1/2, 1/3. It has 4 4/3. And so we need to use this one right here. And we get to choose whether we do this or we do this. And so both of them will give you the same answer. And so this would be, because the denominator is 3, that's your root. So the cube root of 8 raised to the 4th, or, so that was using this property right here. See how m is the exponent in there? Or you could write this as the cube root of 8, the whole thing, raised to the 4th. Your choice, using this property right here. So whichever one is good for you. Now, if I was to do this one, now I'd have to figure out what 8 to the 4th is, which is 8 times 8 times 8 times 8, right? Of course, I could put that in my calculator, which is a really, really big number. I could have written it like this, right? Would have been good too, but get the same answer. And so then I didn't do that by hand. It's not that I couldn't have done that by hand, but I did not do that by hand. And then now this by hand, it's not one I know. You know, when I'm thinking, what raised to the 3rd equals 4,096? Well, I don't know what raised to the 3rd equals 4,096 offhand. I know small ones, a few of them, and of course you could do it on your calculator. So our calculator has a cube root. It's right here behind the square root key there, and so you have to hit the shift to do it. And the cube root, that's what it looks like, of 4,096 is 16, it says. And so I totally had to, the way I wrote it, had to use my calculator. But I could have written it this way, and then I don't think I would have had to use the calculator, because I do know the cube root of 8. And the cube root of 8 is 2. And then 2 raised to the 4th is 16. And so either way, you get the same answer, but this way, the way I wrote it, was more beneficial on this particular problem, because I could do it by hand. So we did a lovely job on that. Then they remind you of the negative exponent rules that we learned in Chapter 4, and we haven't used them for a really long time. And so, but we're gonna bring up, they're gonna bring them up again. And so I can write this 9 raised to the negative 1/2 with a positive exponent by just simply writing the 9 to the half in the denominator. So this would be the same as 1 over 9 to the positive half. And well, the 9 raised to the positive half is the same as the square root of 9. So this is 1 over the square root of 9. And I know the square root of 9 is 3. So this is 1 over 3. And of course, you could put that in your calculator and verify that that's what you get. You do want to do these by hand if what you're wanting to go into is a science field. You don't want to always have to grab your calculator. I haven't taken your calculator away from you, and so I would like you to do both. I'd like you to practice it both ways. And so sometimes people say, well, I'm not going to do it by hand. I'm just going to do them all on my calculator, and no one will know. And believe you me, someone's going to know in your future, because you're going to need to be able to know these, like you know adding and subtracting and multiplying and dividing. And so it's a good opportunity to practice them if what you're wanting to be is some kind of person that has gone into science or math or technology. So this is going to be 1 over, right, because the negative exponent, 4 to the 3rd, 3 halves, right, which is that's my square root. So I'm going to write this as 1 over the square root, so of 4, and then I'm going to raise the whole thing to the 3rd, right, using that property. And the square root of 4 is 2. So this is, oh, I already had my equal sign there. My chair is squeaky, I know. I was using a chair that wasn't so squeaky last week, to the 3rd, which is 1 over 8. And I got to talking so much, I think I better check it with my calculator. But I had a chair that wasn't too squeaky, but it was hurting my back. And so you know how you don't really have things for this kind of work at your house. And so I know I've been using Skype, not Skype, but Conference Zoom with people, and so people are sitting. I see you guys sitting in your bed doing your schoolwork and whatnot. And I know it's because you don't have the setup at home like you would at the library, right? And so I miss school so much, right? Okay, and so I just put here all the rules of exponents that we learned these all in Chapter 4. And they kind of have some properties of exponents for us to practice here. right here. So they say use the properties of exponents to simplify each of the following as much as possible. Assume all bases are positive. The bases are the variable, and so anyway, so this is problem 62, and it's the power rule, right? I have an exponent to an exponent, so I would multiply those exponents together, 2/3 times 3/4, right? So that's in my thoughts. And the 3's cancel, and the 2 and the 4 cancel with one another as well, and that's half. And of course you can put that in your calculator. So this is a to the half. And they didn't tell us whether or not they wanted us to write it as a to the half or if they wanted us to write it as the square root of a. They're equivalent to one another, these two things, right? And so I don't know which one that they were hoping for. But they're either one would be good here because they didn't tell us write it in exponential notation. That's exponential notation. Or write it in radical notation, and that's radical notation. We have the square root, right, as a radical. And so this one here is, I got the quotient rule going on. And remember, the quotient rule is the numerator's exponent minus the denominator's exponent. And so for my a's, that's going to be 1/3 take away 3/5. And you could use the calculator to figure out what that is, and that's going to be your exponent on a. And so, so you can do that in the calculator, 1/3 minus 3/5. And I can put it with fractions, or I can put it with division like I did there, which is negative 4/15. Or you can do it by hand if you like. So this is negative 4/15. And then b. And then that's b to the 4th, and then it looks like a 1/3 to me. I was having a whole bunch of time in it, and in fact, my printer at home, my poor son came in and spent more than an hour getting my printer working so that I can print these papers. I decided not to travel down to the school because they're not open, and so for me to get the print that I needed, and so. Anyway, long story short, thank you, Tyler. That was really nice. And actually, Kevin, they were both here fixing the printer. It kept jamming, and so and then the ink smudged a little here. Now they told us to simplify as much as possible and assume that all bases are positive, and so. Remember that when we had exponents that you didn't want to write a negative exponent, so we want to put this in the denominator. So this is b to the 11/3 divided by a to the 4/15. And so there we would have that. And so we just move that to the denominator. I don't think that writing this one in radical notation would be that great, because it would be a 15th root is what it would be. And up here would be a cube root. You'll see in Math 1 that they'll ask you to write them in radical notation and use the same root. And so you can already kind of see that, well, then you would want the denominators to be the same in order to do that. And you could see how you could make those denominators the same here. I don't think that's what they're asking us to do here. They're just asking us to practice, oh, you have to subtract. Okay, so there, that ends 8.1. I hope that you go and look at the daily incentive point that goes with 8.1 that I posted. And so I'll check you in the next video on 8.2.